Board members, the purpose of this briefing, I'm going to do a very thorough PowerPoint, and the goal here is I want to give an overview of the rainfall event, help kind of give a bigger picture understanding of the data that's considered by operators throughout a storm event like this. We'll go over some of the gate operating principles, and then I'm going to go over some of the answers to what we have received as very common questions, not just in this event, but any of the large storm events that we've managed. Before I start, I do want to express the very sincere thoughts and prayers of all the SJRA staff for everyone that's dealing with the aftermath of Hurricane Harvey. We know this was a very destructive and catastrophic rainfall event, impacted a lot of people. Secondly, I do want to make note of and thank for the record all of the emergency officials and law enforcement personnel that we partnered with throughout this storm event. Like any storm event that we cover, we partner with emergency management and first responders in Harris County and Montgomery County throughout the event. In fact, we do tabletop exercises from time to time to practice the various roles that we all play in those events, but during the storms, they're the ones that are out in the field managing evacuations and road closures, and we certainly want to note and appreciate their efforts on that and their partnership. All right. First part of this, I've got a number of slides that will walk us through basically a time sequence of the storm. I'm going to start on Friday, August 18th. This was 7 days prior to landfall, and one of the things that we do during all major storm events is we begin participating early on in the development of a storm in daily briefings with the National Weather Service. And these briefings include emergency responders all up and down the Texas Gulf Coast. And they prepare a briefing packet. And they generally start out once a day. And then as the storm event gets closer, they will increase the frequency to 3 times a day on these briefings. So a lot of the slides I'll show you today come from those briefings. This was Friday, August 18th. This was the afternoon briefing. This is, as I mentioned, 6 or 7. This is 1 week, 7 days prior to landfall. At this time, the information from the National Weather Service was that the storm posed no immediate threat to southeast Texas. I mean, you can see that the track is still into Mexico. 6 days prior to landfall, on Saturday, August 19th, the storm actually dissipated. So basically, Harvey became just an area of low pressure east of Central America. You can see it there in the Gulf. And the storm essentially dissipated at that point, 6 days prior to landfall. Now, on August 22nd, 3 days later, the low pressure area had moved over the Yucatan Peninsula. And this is the briefing data from the 8 a.m. or the morning briefing from National Weather Service, noting that the remnants of Harvey were likely to redevelop into a tropical storm or hurricane as it left the Yucatan Peninsula and entered the Bay of Campeche. But the track details that we were receiving at this time noted that the track was still uncertain. And during that briefing, we also received rainfall predictions. And at this time, the rainfall predictions were basin averages of 4 to 8 inches. So I heard one news report where someone stated we knew 2 weeks ahead of the storm that we were going to get 50 inches of rainfall, and that was certainly not an accurate statement because, as I mentioned, 1 week out it dissipated into a low pressure area, and then here on the Tuesday, but prior to landfall, we were receiving forecasts 4 to 8 inches in the basin, which is not really a major storm event for our area. Now, August 23rd, so this is Wednesday, this is 2 days prior to landfall. In the morning briefing on Wednesday, the National Hurricane Center began issuing advisories on Tropical Depression Harvey. We also received, again, updated precipitation, updated rain forecast for the event. And the bottom right graphic shows the prediction. They were estimating 10 to 15 inches near the coast. But the further inland from the coast, the lower the rainfall amounts, as you can see from the graph on the right. And the numbers are a little hard to see, but basically the Lake Conroe watershed is in the 6 to 10 inch rainfall zone, and then Harris County and south of that was in the 10 to 15 inch or greater rainfall zone. Now, later that day, this is still Wednesday, 2 days prior to landfall, you've got at our 4 o'clock briefing, updated rainfall forecast. This is the latest information. I'm going to zoom in on that prediction. So that afternoon, still the Lake Conroe watershed, which is the arrow on the left, was in basically the 6 to 10 inch rainfall band in terms of prediction. In Harris County, south of us, Lake Houston watershed was in the 10 to 15 inch rainfall band. Now, moving on to Thursday, August 24th, and you can see the location of the storm at this point, 1 day out from landfall. The notice from the Weather Service indicated that Tropical Storm Harvey was intensifying, so we were getting updated information. This was the morning briefing. And this is the updated rainfall that we received at that morning briefing on Thursday. And still, it's a little hard to see, but the Lake Conroe watershed is still in basically the 6 to 10 inch band in terms of rainfall estimated for the event. This is a multi-day forecast. Now that began to change at the 4 o'clock briefing that afternoon. They began to increase, and this is Thursday's 1 day out from landfall. They began to increase the rainfall estimates. So I'm going to zoom in. This is from Thursday morning, from the 11 a.m. briefing to the 4 p.m. briefing on Thursday. You can see that on the left, we were still in that 6 to 10 inch zone in terms of rainfall estimates. And by the afternoon, they had upgraded us to the 10 to 15 inch rainfall estimates for Montgomery County, but still southern Montgomery County, Harris County, they had increased that to the 15 to 25 inch estimate. At that same briefing, and these briefings are, several, probably 24 pages typically. There's a lot more information that's provided. But one of the other pieces of information they provide is from the River Forecast Center. And they provide all of the emergency response agencies with predictions of the different river basins that they expect to reach major or record flood level. And at this time, on Thursday, you can see most of the basins that were expected to reach flood stage are still basically south and southwest of Harris County. And they're listed there on the left. So on Friday, August 25th, Hurricane Harvey made landfall at Rockport, Texas. You see the track that was issued at that time. In terms of the general forecast for our area, the Weather Service was basically telling us at this time that they were expecting no changes in terms of the general warnings or forecast. In terms of rainfall, they were still estimating 15 to 25 inches, now even areas that might be greater than that, but less rainfall further inland. That was basically the pattern throughout the storm event. So looking at the rainfall prediction specifically, and this is the 11 a.m. Friday morning briefing, the day of landfall. I'll zoom in on that graphic. Lake Conroe watershed is basically now in the 8 to 15 inch rainfall zone, and you've now obviously have greater than 15 inches throughout all of Harris County and further south, even in isolated 40 now is being mentioned in the rainfall predictions. On Saturday, so this is the first day after landfall, this is a current track that was issued at that time. Our area began receiving heavy rainfall on Saturday. In fact, here at the dam, the rains began around 1 a.m. Saturday morning. It's just one of the radar images. They began issuing the rainfall predictions on a daily basis, so you can see on the left graphic was their prediction for basically Saturday night, and then you've got Sunday night on the right, and then Monday, and of most interest to me was the 5-day total. So still, the 5-day totals were 8 to 15 inches for the Lake Conroe watershed over the course of the event. And this is just that same graphic zoomed in. So this is the Saturday morning briefing, and it's still 8 to 15 inches estimated for Montgomery County, well, the Lake Conroe watershed, the north end of Montgomery County and above, because our watershed extends into Walker County. And then greater totals estimated for the Harris County and all of the areas south of us. At the 4 o'clock briefing on Saturday, they still were gradually increasing the rainfall estimates. You can see we're now in the 10 to 15 inches plus. So that area of high rainfall is creeping north as each briefing occurs. just to show some of the radar images that were issued at that time, Saturday afternoon, and you can begin to see, and all of us experienced, frankly, the very, very heavy, rapid rainfall bands that began to move through the region. In terms of lake level, so operationally, staff was on alert, materials and fuel, et cetera, pre-positioned, essentially constantly throughout hurricane season, but certainly a week at least prior to this event. We entered this event with Lake Conroe at about 7 or 8 inches below its normal pool level. So we were 7 to 8 inches low prior to this rainfall event. And 201, the red line on the graphic, is the normal full pool elevation for Lake Conroe. And you can see the blue line, and that's the 26th, Saturday morning, 1 a.m. midnight of Friday night. That shows the rain. That's when the rainfall began. And you can see the lake begin to climb throughout the day on Saturday. And so we received 6 inches of rainfall on Saturday, and you can see the corresponding increase in lake level. We were able to continue. Basically, we're below 201, so we're not into operational protocol yet. But that was the rainfall and the reaction on Saturday. Now, Sunday, so this is the second day after landfall, the 27th. See the track of the hurricane. Obviously, our entire area is beginning all day Saturday and certainly Sunday morning, receiving extremely heavy rainfall amounts on Sunday. I circled the gauge. A gauge in Magnolia, Montgomery County, had already recorded 17.8 inches of rainfall. Here's another radar image from during the event. You can see the prediction. So this is the 4 o'clock briefing on Sunday, and that top left, that's saying several inches of additional rain still possible. So, they were tracking 4-6 inches plus in very short periods all day on Sunday. And then, of course, the rainfall prediction. This is the 5-day rainfall prediction that was issued, and still it's that 15 to 25 inch prediction additional from what had already occurred up through the 4 o'clock p.m. briefing on Sunday. In terms of lake level, this is the lake level reaction for, essentially this graph shows Sunday and Monday. We received 13 inches of rainfall on Sunday. For comparison purposes, in the 1994 storm event, in that event total, our area received 13 to 15 inches of rainfall for that entire rainfall event in 1994. We received that on Sunday alone after already receiving 6 inches on Saturday. So you can see the corresponding rise in lake level. We passed the 201 mark Saturday night, early Sunday morning. So you begin to get into the operating protocol phase where you begin to have to open gates, and I'll go over some of that later in the presentation. And you see that by the end of Sunday, the lake had risen 4.5 feet in that single day. Okay, going forward to Monday. This is the third day after landfall. It's the current track of Harvey. The heavy rain bands were beginning to move to the east, but still on Monday, rain bands were being created right in the Harris County area still, but a lot of the heavy bands that would swing out from the hurricane were moving towards the east. But even on Monday, this is the 11 a.m. briefing. Monday morning, we had received, remember, 6 inches Saturday, 13 Sunday. We're sitting down for the 11 a.m. briefing on Monday with the Weather Service, and they're still predicting an additional 6 to 10 inches of rainfall over the next 3 days. This was a radar image from the 4 o'clock briefing on Monday, and just to point out that there were notes like this: rainfall amounts 4 to 8 inches just that afternoon. And so there were bands still forming in the greater Houston region capable of producing extremely heavy rainfall amounts even on Monday. The rainfall predictions that they issued at this time, this was for Monday night and Tuesday. You began to see a little bit of reduction. We were predicted to have 1 to 4 inches through Tuesday. But for the 3-day total, this is the Monday afternoon briefing. They're still predicting an additional 4 to 6 inches in the Lake Conroe watershed for the next 3 days. So on Tuesday, August 29th, Harvey was still out over the Gulf. It was gradually, very slowly, moving to the east. This was a radar image from the 11 a.m. briefing on Tuesday. Again, you can see the heavier rainfall beginning to move to the eastern side of Harris County and out in the East Texas. We received, as part of these briefings, again, lots of River Forecast Center update information. I just wanted to note, this was a note they inserted into their update that the discharge at Lake Houston, August 28th, they recorded at 6:30 p.m. approximately almost 400,000 cubic feet per second being discharged from Lake Houston, which surpassed the previous record set in 1994 in that storm event. Tuesday morning at the morning briefing, 10 a.m., 11 a.m. I guess, we were beginning to see slightly reduced rainfall estimates for the remainder of the event. So at this time, you can see we're basically in that 3 to 6 inch, we're in the, half-inch to 2-inch rainfall band at that point. So less than 2 inches predicted at that point. This is for a 2-day forecast in the Tuesday morning briefing. So less than 2 inches predicted for the remainder of the event. On Wednesday, August 30th, this is the 5th day after landfall. The event had basically, in terms of rainfall, the event had essentially passed in our region. Weather Service began compiling rainfall totals for the event throughout Harris County. I'm going to zoom in a minute on that rainfall total graphic on the left, and then the graphic on the right from the River Forecast Center showing the various basins that were still at major or record flood stage at this point in the event. And then here is the zoomed in version of that rainfall graphic. So we all know the totals. I mean, we had 40 to 50 inches in southeast Harris County, just an extremely large area of over 20 inches of rainfall. But just the size and magnitude of the rainfall in this event and the geographic area that it covered was enormous, unprecedented. And just to sort of expand on that point, I want to compare this rainfall event. So if you think about this 20-plus zone, so all of the dark kind of purplish blue area that's 20-plus inches, I want to compare that to Tax Day and Memorial Day. So if you'll kind of keep that image in your mind, this next image is the Tax Day event from 2016. In this event, these couple of white areas in the graphic represent areas of 15 inches or better. So even though Tax Day was an enormous rainfall event and produced a tremendous amount of flooding, you can see the areas of the concentrated heavy rainfall were not nearly as extensive as in Harvey. And this event was essentially a West Harris County and west through Austin County and west of there was the shape of this event on Tax Day, and you can kind of see the different rainfall areas. And then if you go to Memorial Day, in this event, the white blocks on the graph are areas where the rainfall exceeded 20 inches. But again, the areas with rainfall totals over 20 were geographically a fairly small area. Now, Spring Creek, Cypress Creek, Lake Creek, all of the basins on this western portion of Montgomery County received very, very high rainfall totals on Memorial Day, but the geographic extent of those rains was not nearly what was experienced in Harvey. Now, in terms of how that impacted our basin, how Harvey rainfall totals impacted the basin, we produced this peak flows map. Basically, all of this data is pulled from the USGS stream gauges that are throughout the basin. So each of these data points can be verified on the USGS website. You can look back at the historical data and see the totals at each of the gauges. And the point of this graphic is just to demonstrate, I didn't mark on here which basins set new records, but I can assure you they were all or nearly all at or above record levels. And so starting with Cypress, you had 28 100,000 cubic feet per second at the Cypress gauge, and the little blue raindrops are the rainfall totals for those areas. And every one of these watersheds are part of the Lake Houston watershed. Every one of these basins flows eventually into Lake Houston. You had Spring Creek at almost 83,000 cubic feet per second, and then I'll just bring in the other basins. And this isn't all of the tributaries that feed into Lake Houston. This is really the major tributaries that feed into Lake Houston. And you had 130,000 cubic feet per second in the West Fork at Porter. So this is right before the confluence. This area is the confluence between the West Fork of the river and Spring Creek and Cypress Creek. Now, in terms of Lake Conroe, during this event, we estimated from the measurements taken at the lake 130,000 cubic feet per second as the peak inflow into Lake Conroe. The peak release rate during the event was 79,000 cubic feet per second. And I'll touch in a little bit in some more detail on how that peak inflow coming into the lake is reduced as it passes through the reservoir. Just a quick comparison of some of the various the record events here at Lake Conroe, just to put these in perspective. I'm just showing here the peak lake level in the first column, the peak release rate, and then the rainfall rate. By the way, I meant to mention at the beginning of all this PowerPoint will be available on our website after the board meeting today for anyone that would like a copy of it. So you can see the lake level and release rate for Harvey in the top row, and that was based on measured over 22 inches of rainfall in the Lake Conroe watershed, 13 inches as I mentioned earlier on Sunday. You can see how that compares to the 94 event. So 94, the lake rose to 205.6, slightly over 4.5 feet over the normal pool level, had a peak release of 33,000 cubic feet per second with 13 to 15 inches of rainfall during that event. Memorial Day and Tax Day are also noted on here. And if you recall, the Tax Day rainfall really was sort of centered around Harris County and west. So the Lake Conroe watershed didn't receive nearly as much rain, well, 7.5 inches of rainfall on Tax Day. So you can see our release was very low in the Tax Day event. Memorial Day, 9.5 inches, and higher lake level, higher release. And the other thing that's not captured in this graphic, the lake level and the release rate depend highly on the duration and the intensity of the rainfall. And I didn't attempt to try to capture that on this graphic, but how fast the rain falls and runs into the reservoir has a tremendous impact on how the reservoir reacts. So that's basically a summary of the rainfall event. Now I want to touch on just some of the key points regarding the operations of the dam, how it works, and I'll do that by walking through a few of sort of the answers to some of the commonly asked questions that we received during all of the major storm events, and especially Harvey. This is just an overview of the dam. The embankment's a little over 2 miles long, and the spillway, the overflow spillway gates are here in the middle, and we have an additional release point, but this is a low flow release outlet, service outlet for releasing low flows to downstream customers. So the first point, we were frequently asked, why didn't you just hold the water back, or why did you open the gates at all? I mean, that's been a common question. So I'll basically walk through and explain that Lake Conroe is a water supply reservoir. It is designed essentially to operate at a full level. You want to keep the lake as full as possible, as long as possible. The goal is to store water for water supply purposes. Now that's compared to a flood control reservoir like Addicks or Barker, where the reservoir is designed to basically stay empty and leave a lot of storage space to capture inflows during a storm event. So what that means is water supply reservoirs have very little freeboard, very little space, and I'll show those in some graphics in a minute. Very little space to capture inflows. They are designed to basically pass inflows that come into the reservoir during a storm event. That's how they're designed. Now structurally, a Tainer Gate reservoir like Lake Conroe is designed so that you release the water from underneath the spillway gates. They are not designed to allow water to flow over the top of the spillway gate. So here's a picture of the spillway from downstream, looking back up at the gates. Each gate is 40 feet wide and 30 feet high. You can see this is previous image showing water flowing under the gates. This is a close-up picture. Now we're looking at the downstream and upstream side of the Tainer gates. And the point of this, the primary point, is to show where the top of the water surface falls. So if you're looking at the upstream side of the gate, when the dam is at, or the reservoir is at the normal full level, there's about 18 inches of space between the water level and the top of the gate. That's the freeboard that remains when the lake's at 201, or normal surface elevation. And you can see if you transfer that line to the backside just to show it from this direction, you know, that's about the 18-inch point. That's about where the water level falls when the lake is at normal pool elevation. So to kind of demonstrate what you're dealing with in a storm event, you start the event basically full. We were 8 inches low in this event, but at some point in an event, you're going to reach your full level, and you've got that 18 inches of freeboard. In this event, in Hurricane Harvey, we have passed over 15 feet of lake level. So all of the rainfall and the inflows into the reservoir resulted in an additional 15 feet of water on the reservoir. So there's no option to not open the gates. If you don't open the gates, that wall of that water will flow over the top of the gate, and structurally that is not how they're designed. They're not designed to sustain that type of pressure of sheet flow over the top of the gate. But if you didn't open it, the water is going through the reservoir whether you open the gates or not. So there's simply no option to not open the gates. That's not how a water supply reservoir operates with a Tainer gate system. Now, just another way to look at that, this is that same image on the left with the gates closed at normal level. And then as the water rises, you have to gradually open the gates to keep the top of the gate above the level of the water. You do allow the lake level to rise. During an event, the reservoir is designed to allow the lake level to rise temporarily during a storm event, which mitigates, it actually reduces the peak flow going through the reservoir, which I'll show in some graphics in a moment. But then that lake level, after the peak of the event passes, the level gradually drops back down and you can gradually lower the gates back down. Now the next point I want to make about Lake Conroe, we've obviously heard numerous questions and claims that the Lake Conroe causes flooding. That's simply not the case. Water supply reservoirs like Lake Conroe, even though they are not designed for flood control purposes, do actually mitigate the peak flow of an event as it passes through the reservoir. That's possible due to the operating buffer that the lake is assigned. Now for Lake Conroe, that's a 6-foot zone. At the time the lake was constructed, there was a 6-foot easement purchased around the reservoir that allows the lake level to go up and down 6 feet during a storm event for operational purposes. The operating protocols for how the spillway gates are operated are designed basically to balance the inflow with and lake level with releases. So the computer is calculating throughout the event how much water is currently coming into the reservoir. You've got 6 feet to work with, and you've got to safely pass the peak flow through the reservoir while lowering the flow as much as possible. So for this event, one of the ways to show that graphically is to compare some of these hydrographs. Now this black line is the flow rate at I-45. This is the West Fork of the San Jacinto River at I-45. And this is a measure of the flow rate at that location over time. So you can see the peak flow at I-45 was just under 120,000 cubic feet per second. The blue line is the discharge from the Lake Conroe Dam. Now this is measured basically about a mile downriver at Highway 105. That's the blue line. Now at this point, that's the 78,000 cubic feet per second. That relates to the peak discharge from the dam. The peak inflow, if the dam had not been here and had not operated as it's designed to operate, the peak inflow into Lake Conroe was 130,000 cubic feet per second. That's the flow that would have gone down the river if the Lake Conroe Dam were not in place, operating as it's designed to operate according to its protocol, and using that 6-foot flowage easement to buffer the flows going downstream. So the difference basically is that amount of water that's temporarily detained in Lake Conroe and allowed to be released over several weeks or months after a storm event. Another graphic just to demonstrate that effect. This is more hydrographs from the event. So the two dashed lines are Cypress Creek and Spring Creek. Those are the flows at Cypress Creek and Spring Creek at the gauges measured by the USGS. The solid lines, the yellow is Lake Creek. The blue is the discharges from the dam measured at Highway 105. And then the orange is the flow at I-45 and the green is the flow at Porter. So this is basically going downstream as you add basically Lake Creek and the discharges from the dam combined together, and then you pick that flow up at I-45 and eventually at Porter. And again, if the Lake Conroe Dam had not been here, had not utilized the 6-foot flowage easement that it's designed for, then that is the comparison of the 130,000 cubic feet per second that would have flowed down the river and made the situation much worse downstream. All right, the next important point about Lake Conroe relates to all of the watersheds that eventually flow into Lake Houston. This graphic, and I'll zoom in a little bit in a minute, just shows the various watersheds in the entire greater Houston region. You've got Lake Houston here on the right-hand side. And the point of this is that the Lake Conroe watershed makes up approximately 10 to 20% of the total flows that eventually reach Lake Houston. So if you zoom in a little bit and just show basically the watersheds that feed into Lake Houston, you can see starting with Cypress Creek on the lower left, working your way around all the way to Loose Bayou on the east side. We get a tremendous number of calls also from people wanting to know, is the flooding at my location related to the releases from the dam? The water, all of the water in these watersheds, if the rain falls in the Spring Creek watershed, it flows into Spring Creek, down Spring Creek until it reaches the West Fork at the confluence, which is almost at Highway 59. So we provide these watershed maps so that we can answer these questions and explain to people that for Lake Houston, Lake Conroe watershed, which leaves Lake Conroe and flows down the West Fork, makes up about 10 to 20% of the total flows reaching Lake Houston. In the woodlands, west of I-45, the impact from the Lake Conroe releases is zero. The woodlands is on the Spring Creek watershed 15 miles upriver from the San Jacinto River and is not impacted by releases from Lake Conroe. There is a portion of the woodlands, Harper's Landing, on the east side of 45 that is closer to the West Fork of the San Jacinto River and is impacted by flows from Lake Conroe. But Tomball, we received calls from Tomball. We received a number of calls from Wood Forest subdivision. These are in different watersheds uphill from the San Jacinto River, not impacted by flows from Lake Conroe. We also saw a news report on TV claim that flooding in Plum Grove was related to releases from Lake Conroe. Not only is that not in the Lake Conroe watershed, it's not in the West Fork of the San Jacinto River, it's in the East Fork of the San Jacinto River. But we deal with these questions in every major storm event. Now, we do have other agencies in the state that are also helping to provide information and get information out there about how the watersheds work. And I want to play a clip from a video. This is from one of the press briefings at the Harris County Flood Control District related to the storm.
There are releases going on Lake Conroe, which did go into the West Fork of the San Jacinto River. We are expecting major to record flooding on the West Fork of the San Jacinto River. We will rival the October 1994 flood. But I want to be clear that the majority of the water that is moving down the West Fork of the San Jacinto River is from Spring and Cypress Creeks and Lake Creek, and it is only a very small fraction of Lake Conroe release getting to the West Fork at Humble. So the flooding on the West Fork of the river and potentially the flooding around Lake Houston, the majority of the water is not coming from Lake Conroe. And had Lake Conroe not been in place and been able to hold back some of this water, the flooding would be much, much worse on the West Fork of the San Jacinto River.
All right. So Jeff actually touched on both of the first 2 points. It's a small percentage of the overall flow, and Lake Conroe serves to reduce the downstream impact of rainfall events in the Lake Conroe watershed. And one more time, just to show this again, we've highlighted the peak flows in all of the basins, not all of the basins. There are still some smaller tributaries that feed into Lake Houston, but these are the major basins with stream gauges that flow into Lake Houston. Now, in terms of the impact at Lake Houston, this is the hydrograph showing the water level in Lake Houston. In this event, Lake Houston rose steadily at a rate of about 7 inches per hour over a 72-hour period. As was reported in one event incorrectly, there was no surge in the level of Lake Houston caused by the releases from Lake Conroe. That's simply not how flows work in this watershed. It's a very flat, our entire area is very flat, and the flows are very slow in all of these tributaries. So Lake Houston gradually rose throughout the event. In fact, the travel time for releases from Lake Conroe to reach Lake Houston is over 24 hours. One of the questions we received operationally related to the fact that the heavy rainfall and the rapid opening of the gates, some of that occurred during the night. I think it was midnight Sunday night. However, it's 24-hour travel time downriver, so that allows time for the river to respond. The flows have to gradually make their way, and that's when the notifications are able to take place. All right, the next key point, now this really relates to upstream of the Lake Conroe Dam. At all times during the event, Lake Conroe water level remained within the authorized flowage easement. As I mentioned earlier, when the dam was constructed in the late 60s and early 70s, in addition to acquiring the property for the footprint of the reservoir, the River Authority also acquired a 6-foot flowage easement around the perimeter of the reservoir. This is recorded in the deed records for all of the properties. It allows the properties up to 207 feet mean sea level to be inundated during operations of the dam. In this event, the peak level was 206 1/4, so we stayed within the flowage easement. Here's the graph showing the level during the event, and I've marked in red the flowage easement for Lake Conroe of 207 feet. So I want to just demonstrate that in a few additional graphics. Just from a picture standpoint, just to try to get an understanding of how a flowage easement functions. At a normal water surface elevation of 201, the water would hit the land at a certain point on the shore. Some distance uphill from the shoreline, and it varies depending on how flat the land surface is around the reservoir, you'll reach a contour of 207 feet above sea level. And then wherever that falls on the property, that is the area that can be inundated during a storm event. It's up to elevation 207. This is a copy of one of the actual flowage easement documents. It was pulled from the deed records. This is just a sample. Obviously, there are numerous copies of this for each property around the reservoir. And then this is one of the plats from Bentwater subdivision, and you can see we had to kind of blow up one portion of it. This is the portion in the plat that notes the flowage and inundation easement up to 207 mean sea level. So these are the various notifications that are provided for landowners that choose to purchase property around Lake Conroe. Now, probably one of the most frequent questions we received after this event was, why didn't you let water out of the reservoir prior to the storm event? I have several graphics that I'll use to demonstrate this point, but I'll summarize a few of those first of all. The primary reason we don't ever pre-release from Lake Conroe is because the highest likelihood is that we will make their flooding problems downstream worse by doing that. And I'll demonstrate that with a few different graphics, but it would take weeks to safely lower Lake Conroe's water level for a number of different reasons. And weather predictions simply are not accurate enough that far in advance to make any difference in Lake Conroe's water level. And in fact, when you're dealing with an event like Harvey, where you've got 15 feet of lake level that you have to pass, starting an event 1 or 2 feet below the normal pool level is not going to change the operational situation you're dealing with once you go over 201. So let me walk through a few of those things. First of all, we've made some estimates of, at various release rates, how much change does that make in lake level for a day's time? Now, to try to put this in perspective, 2,500 cubic feet per second, a release of 2,500 cubic feet per second would essentially fill the river downstream of the dam. There are some properties that are nearly impacted at 2,500 cubic feet per second. I wouldn't consider this a safe release rate. The river would stay in its banks, but it's essentially filling the river at many locations. At that release rate, you're only changing the lake level 3 inches per day. That's just one of the things that's hard to understand is the size, the magnitude of a reservoir, the volume of water that's involved. The surface area of Lake Conroe is approximately 20,000 acres. It's a much larger reservoir than Lake Houston. And so even at a release rate of 2,500 cubic feet per second, we're only moving 5,000 acre feet out of the reservoir each day. That only moves the needle about 3 inches in a day. Now, that's certainly not a safe release rate prior to a storm event when you already know rainfall's coming. But if you back that amount down, even to 625 cubic feet per second, now you're only dropping the lake 3/4 of an inch a day. So to lower the lake level, even if we wanted to lower the lake just 2 feet prior to an event, which as I mentioned, 2 feet low going into a 15-foot event, really doesn't help you. Once you'll fill up, you'll get to 201 and you still got 13 feet left to pass. It would take a month to lower the lake 2 feet. And now let's look at the forecast and let's see what sort of information we had going into this event. 6 days out from the landfall of this event, Harvey dissipated, basically became an area of low pressure just north of South America. And then 3 days prior to landfall, the remnants of Harvey, an area of low pressure, were centered over the Yucatan, and it was likely to redevelop into a hurricane. So it's not the 2 weeks ahead that we all knew we were going to get 40 to 50 inches of rain. Even 3 days out, we basically had a low pressure area over the Yucatan Peninsula. And as I mentioned, with that much time, and at this time the forecasts were 4 to 8 inches of rain in the basin. So there's just no set of circumstances under which you can make a release that will make any impact on the ultimate storm operations. And just to recall some of those forecasts, here's Wednesday, 2 days prior to landfall. Conroe, Lake Conroe's watershed is in the 6 to 10 inch rainfall zone south of us. In Harris County in Lake Houston, they're actually predicted to get heavier rainfall than we are here at the Lake Conroe watershed. If you go to 1 day prior to landfall, still Lake Conroe is in the 6 to 10 inch band, and Harris County now is 10 to 15 inches or greater predicted rainfall. There is no way you would send water down the San Jacinto River to Lake Houston under circumstances like this, or frankly under any circumstances, because you simply cannot predict where exactly the rain will fall, how much and how intense it will be. We've had rainfall events where there was flooding in the Woodlands, which is only 15, 20 miles south of here, and we had no rain at the Lake Conroe Dam. You would have to know precisely which watershed the rain would fall in a month or two ahead of time to make any significant impact in terms of a pre-release. That's why it's not done. We actually have a letter from the TCEQ that summarizes these same points. All right, the next point I want to cover relates to just emergency communications during a storm event. Throughout storm events, as I mentioned before, it's a constant partnership with the emergency response agencies in both Harris and Montgomery counties. We do tabletop exercises periodically to work with and practice with our partner agencies on how we'll handle these events. The river authority's role in these events is to operate the dam and notify all of the emergency response and law enforcement agencies that we partner with of the releases from the lake real time as it occurs. we have no authority or ability to order evacuations, to control or manage any sort of evacuations or road closures, or to serve in an emergency response role. We partner with agencies that fulfill that role during a storm event. However, during events, we do provide real-time data throughout every storm event. So there's a number of locations that this information is made available. On our website, we always have a current conditions box at the top right of the homepage, but during storms, we add a large box at the top of the homepage. You're just seeing the very top of it here, that where we post up-to-date information as it becomes available, whether that's press releases, frequently asked questions, maps. We put the peak flow map out as the event is occurring, links to other useful information. But in addition to this, we have a publicly facing website. All of the data that we use during an event. This is rainfall totals throughout the basin from all of our gauges, lake level, release rate. All of the storm data that we monitor during an event is in this Contrail website. And that is a public-facing website. Anyone from the public can pull these dashboards up and monitor live the same information that we're monitoring throughout a storm event. In addition to that, we do produce press releases, receive some criticism from folks that, well, if this is all you put out, obviously that's not getting to people. Well, that's not all we put out. And also, the purpose of these is we've got specific information we've got to get to media outlets. We rely on media outlets to take this information and push it to the broader general public that we can't possibly reach. We also provide it to elected officials, all sorts of local elected officials in cities and other entities, so that as their constituents call, they have up-to-date information throughout the event, and certainly they can always send them to our website. So just to summarize a few things, in hindsight, after looking at all of the data from this event and visiting with our engineers, the reservoir operations during this very unique and terrible natural catastrophe were run very effectively and in accordance with the engineered protocols for the dam. Now, to demonstrate that, in this event, the lake stayed within its flowage easement, but we basically used nearly every inch of that 6-foot flowage easement to let the lake level rise, which means that through the operation of the Lake Conroe Dam, we reduced the flow going down the West Fork of the San Jacinto River to almost the maximum extent possible for an event of this magnitude. So it was a very well-run, successfully run event. Another interesting bit of fallout from events like this is not the only major storm we've had in recent years. Over the last few years, there have been a number of major storm events that caused major flooding. And one of the conversations that's beginning to occur in our industry relates to the design of future reservoirs. There is now discussion in our industry about moving away from Tanner Gate dams like Lake Conroe. Let me explain what I mean by that. So if you take the Lake Conroe Dam, it could have been designed as a broad-crested weir, which is basically a long concrete flat overflow spillway with no gates. That would mean that whatever rainfall flows into the reservoir basically would pass through and flow over this large spillway with very little attenuation or reduction of the peak flow. So you would actually lose the benefit of reducing or mitigating downstream flows, but there would be no gates to serve as the target of misplaced blame. So the litigation and the misinformation that's arisen from major flooding events over the last few years has begun to cause reservoir owners and engineers to think about moving away from Tanner Gate dams. Now, personally, I believe Tanner Gates are the better approach operationally in terms of operational flexibility that they provide, and because of the flood mitigation that they accomplish. Even though it's not a flood control reservoir, they do reduce the peak flow going down the river and reduce downstream flooding. But it requires a tremendous amount of education to help people understand how they function. Now finally, I just want to mention, we have been contacted about participating in a number of studies and investigations to determine if more can be done to mitigate flooding in our region. Those types of studies have included things like additional basin modeling to get a better handle on the topography and the reaction of the rivers and streams to storm events, large-scale flood control projects, channelization of certain streams. There will be a lot of resources available following this event, and every idea certainly will be considered. And we have indicated that we look very forward to participating in any of these studies that we can help with. So that's the conclusion of my remarks, Mr. President, and I'll turn it back over to you for public comment.